Hey everybody, Jake here coming at you with another math lesson today. Doing it live again this Monday evening. Hopefully everybody's having a good Monday so far. Hopefully your week's off to a good start. But today we're going to be going over some product rule and quotient rule examples. Basically examples where you have to use both product and quotient rule in the same problem in order to find the derivative of the specific function. So really before we kind of jump into things with these examples that I'm going to be going over, and I think this is actually going to be something that's pretty common for other product and quotient rule examples. Like what I mean is like functions where you have to use both of those in one. It's pretty common with those problems where before actually taking the derivative, you could probably rearrange the function in a way that you can use some other method maybe to take the derivative, or uh, if you do want to stick with using the quotient rule and the product rule in one, you may be able to do them in the opposite order. So I'll talk a little bit more about that as we go, and how that kind of applies to these specific examples that I have prepared for you. But just to kind of give you that heads up that there is definitely flexibility with how we're kind of working through these problems. So I'm going to show you a certain way. I'll kind of bring up different ways you could approach it, but I'm not going to work all the way through these problems in multiple different ways. But I will definitely kind of point those out as we go. Also, these product and quotient rule formulas, they are both on my free Calculus 1 study guide or my derivative calculus cheat sheet, differential calculus cheat sheet. They're also both covered in a lot more detail in my complete Calculus 1 package. If you want to check out either of those things, there is a link down in the description, or in the pinned comment below. If you're watching this after it's live, the pinned comment below will have that as well. But let's go ahead and jump into the examples I have prepared for you here. Let me just switch over here. All right. So here's the first example we're going to be going over, of having to use the product rule and quotient rule in one problem, and kind of how that works and how that's going to go. So like I said, we're just going to find the derivative of this function. In this case, our function is y equals x to the fourth over e to the x, all multiplied by sine of x. So I talked about this quite a bit in the product rule and chain rule examples that I went over recently. Sorry if you're barking in the background. Went over this in quite a bit of detail. It's going to be kind of a similar method that you want to think about as you're thinking about how to set this up as the videos that or the live stream I did last week, where I talked about product rule and chain rule in one problem and how that works. And that is, you want to kind of think about if you were to actually plug in some x value. So let's say this is some function f of x, and we want to say like f of 2, for example. We want to actually take some x value and plug it in for x here. Think about the order of operations that we would have to go through to do that. Basically, if we were to plug in 2, in this case, let's say, we would figure out 2 to the fourth power first. At that same time, we would also figure out like e to the x. So basically, we'd be dealing with this by itself, this by itself. Then we would divide these two things. And then after that, we would multiply it by whatever we get from sine of 2. So if we're thinking about just kind of order here, first we would deal with, I probably should have done these in different colors, but first this green circle and this green circle, okay? Then second, we would deal with this division, basically figuring out the overall value of this whole circle. And then after that, the final step would be this multiplication of multiplying by sine. So basically, if we're thinking first the green one, then the orange one, and then the red one. That would be kind of the order of operations that we would go through actually figuring out what this whole thing equals. So when you're thinking about whether we want to apply product rule or quotient rule first, you want to do it in the opposite order of what the order of operations says you would do if you were plugging in some x value. So basically, we would want to deal with the product first. In other words, do product rule first, and then work our way in from there. So you really only need to figure out what you want to do first, and then the rest will kind of reveal itself as you go. So what I mean by that is we could first apply product rule. So first thing we want to do when we're applying product rule is look at where our product, our multiplication is saying we have the product between what two functions. Well, it's going to be this whole parentheses, x to the fourth over e to the x. So x to the fourth over e to the x. And then our other function that we're multiplying that by is sine of x. So basically just figure out what are the two main big pieces that you're multiplying together, call one of them f and one of them g. And then we'll be able to kind of work through the product rule process from there. So the product rule basically says once we kind of decide what our f and what our g are, and like I said, this formula is on my free Calculus 1 study guide. If you want to check that out, there's a link down in the description below where you can go get yourself a copy of that. It is free. It's available for instant download. So go check that out. But what we have to do with product rule, once we figure out our f and our g, we have to then figure out our f prime and our g prime. So f prime is really just going to be the derivative of whatever f is. G prime is just going to be the derivative of whatever g is. So g prime, the derivative of sine of x, is just going to be cosine of x. That's pretty straightforward. That is also on my Calculus 1 study guide. You'll probably want to just kind of memorize that the derivative of sine is cosine. But now to find the derivative of x to the fourth divided by e to the x, to find that we actually have to use the quotient rule now, because now we're finding the derivative of some fraction divided by some other fraction. So now we're going to have to implement quotient rule. So let's just kind of create like our own side problem out of this. Let's say basically we're going to now find the derivative of y equals x to the fourth over e to the x. Well, that is going to use quotient rule. So quotient rule says, and then we're going to kind of, like I said, we're creating a little like side problem over here. So we're going to say f and g again. Do keep in mind, this is just within kind of what we're doing here. So maybe what we should say actually is f sub 1 and g sub 1. And then what we're going to have to find next is f sub 1 prime and g sub 1 prime. So this f and g is different from the f and g we had up here. This is our product rule f and g. And now this is our kind of side problem quotient rule f and g. So you want to be sure to keep them separate. So with quotient rule, what quotient rule says is we're going to always make f our top function. So we would just say x to the fourth. And we always want to make g our bottom function. So that's just going to be e to the x. Then you want to think about finding the derivative of each of these things. So the derivative of x to the fourth, we could find just using the power rule. We're going to bring the 4 down in front, leave our x as x, and then minus 1 from the power. 4 minus 1 is 3. The derivative of e to the x is just e to the x. It is a very unique function where it is its own derivative. So now that you've figured out these 4 pieces, what you want to kind of think about is, well, basically just the quotient rule formula, which, like I said, is also on my study guide. Link is down in the description. But the other way to kind of think about this, rather than thinking of it as f and g and f prime and g prime, you just want to think of low d high minus high d low, all over low squared. So low d high minus high d low, all over low squared. So that just means low is the bottom, which is what we said was g here. D high is the derivative of the top, which is f prime. So basically we're going to get g times f prime. So e to the x times 4x cubed minus high d low. High is just the top, which is x to the fourth, which is what we said our f was, minus x to the fourth, times d low, which is just the derivative of the lower part of our fraction, the derivative of the bottom, which is g prime, which is e to the x. So times e to the x. And that's all going to be over low squared. The bottom of our fraction, the low part of our fraction, e to the x squared. So this is the derivative of this y here. Well, now keep in mind, this y here was just our product rule f. So now this y prime down here, we could just actually probably call that y sub 1 and call this y sub 1 since we're doing sub 1 for all this stuff. This right here is now going to be the f prime from our product rule. So we're basically just going to say, and actually we can simplify this a bit before we do that. Check out what we have here. We have two terms on the numerator of this fraction, two terms on the top. Both of them contain an e to the x. So we could basically factor out e to the x out of our numerator here. We'd be left with 4x cubed minus x to the fourth. And then on the bottom here, we have e to the x all squared. So basically the top and the bottom of this fraction have an e to the x term. So this e to the x is going to cancel with one of the e to the x's down here, just leaving us with e to the x. So basically this whole thing will simplify down to 4x cubed minus x to the fourth all over e to the x. And like I said, that is going to be our product rule f prime up here. So now we'll go ahead and put this 4x cubed minus x to the fourth all over e to the x. And we're going to put that right here in our f prime spot. So now that we have kind of completed that side problem of applying the quotient rule, we can now go back to the product rule. So product rule says we're just going to figure out our f, our g, our f prime, and our g prime, and then we're going to multiply these across. So we're going to do g times f prime, f times g prime, and then add those two things together. And it doesn't really matter what order you do it in. You just need to make sure that you're multiplying the right piece with the right piece, the right piece with the right piece, and then adding the result. So basically, we're just going to get x to the fourth over e to the x. So y prime is going to be x to the fourth over e to the x times cosine of x plus 4x cubed minus x to the fourth all over e to the x times sine of x. So now from here, we could definitely do some simplifying to, simplify this down a bit, cancel some stuff out. For example, basically we have two terms here now at this point, that term right there and that term right there. Think about what these have in common. Well, they both have, on the numerator up here, we have these terms right here both have x cubed. So actually, the first thing we could do is pull out an x cubed from this numerator. And that would leave us with 4 minus x right there. So basically, that would just kind of factor out like that. Okay, so now this term has an x cubed right here. This term has an x to the fourth. So they basically have an x cubed in common. And then they both are being divided by e to the x. So they both have an e to the x in common. And then the sine and the cosine is not in common. So if we pull out x cubed over e to the x from here, we're going to be left with x right there times cosine x. If we pull out x cubed over e to the x from here, we're going to just be left with 4 minus x. So plus 4 minus x times sine of x. So now this is going to be our y prime based on the product rule and the quotient rule kind of within that as well. So that should be the final derivative there. All right, I'm not seeing any questions in the live chat. As always, if you are watching this live, feel free to drop any questions you have in the live chat as we go. I do want to mention real quick, since I kind of brought up at the very beginning of the video, that we can kind of do this in another order. So what I mean by that is, think about how we have this written here. Like I said, we want to kind of think about order of operations and do the reverse order. Since the multiplication or the product is the final thing that we would have had to do if we plugged in a number into this equation, that tells us product rule is the first thing we deal with. However, think about this. We could have rewritten this. This function is exactly the same as x to the fourth times sine of x all over e to the x. So now think about, if you were to plug some x value in here, what order would the order of operations say that you deal with stuff? Well, first of all, you would deal with, again, this x to the fourth term, and then deal with this sine of x, and then you would multiply those two together. And then the final thing you would do would be this division. So if we were to kind of rewrite this function in this format here, the final thing we would have to do if we were plugging in some x value into that would be the division. So since dividing is the final thing we do, the quotient rule, which tells us how to deal with derivatives of fractions, would be the first thing we would want to apply. So we would basically call this our top function, call this our bottom function, and go through the quotient rule first. And once we got to the point where we had to find the derivative of this top function, that would then require the use of the product rule, because this is the product of x to the fourth times sine of x. So you can kind of rewrite it and do it in whichever order you want. You just want to make sure you're keeping track of, which function you're basically doing or using, and keeping track of what's your numerator, denominator, product one, product two, whatever the case is going to be. You can kind of rearrange multiplication and division, though, to do one versus the other first or second. However, it's not going to matter. You're going to end up with the same thing at the end. You're going to end up with this function at the very end anyway. It really doesn't matter what order you do it in. So yeah, go ahead and, if you don't believe me, test it out. Go through quotient rule doing this function here and see what you end up with. I bet it's going to be the same as what we got. All right, so this next example here we're going to go over is we're going to find this derivative of y equals sine of x times x squared plus 2 all over the square root of x. So again, let's think about the order that we're doing this. I'm going to go through this one a little bit quicker than I did the last example because it's going to be similar thought process. Think about if we were to plug some x value into this function. What order would we deal with things? The first thing we would do is deal with the sine of x and what we have in the parentheses here, x squared plus 2. We would deal with those two things first, okay? Then the second thing we would deal with is the product. We would then multiply those two things together. So that'd be our second step. Then the final thing we would deal with, and actually I guess at the same time as the first step, we would kind of deal with this also. So basically these three things would be dealt with individually right off the bat. Then we would multiply those two things together, basically figuring out what the numerator of our fraction is. And then we would deal with this division. So that dividing would be the final third step that we would go through. So basically, since that dividing is the final step we would go through, whatever the final step you would go through when you're plugging some number in for x and figuring out order of operations, that's going to be the first thing we have to deal with when we're trying to take the derivative. So dividing is going to be the first thing that we have to deal with. We're going to want to start with quotient rule. So quotient rule says basically what we need to do is, like I said in the last example, we need to figure out what is the top of our fraction and what is the bottom of our fraction. So the top of our fraction is just everything on the numerator, and the bottom of our fraction is everything on the denominator. So that's, pretty straightforward. So like I said, if we're using quotient rule, the formula for quotient rule basically says if y is high over low, so the high part of the fraction over the low part of the fraction, the derivative of that is going to be low d high minus high d low all over low squared. So this version of this formula is actually one of the formulas on my study guide. I think this is much easier to remember how to apply when you're doing these on a test or on your homework. Really just doing them on your own. This formula I think is easier to remember. It kind of has a little bit of a jingly ring to it. Low d high minus high d low all over low squared. Sorry, that should be squared. So basically, we just need to figure out the high is going to be what we have on the numerator here. High, not ho. And then the bottom is going to be what we have on the numerator. The low is going to be, I'm sorry, not numerator. Getting my words all tangled up here. The low is going to be the low part of the fraction. Basically, just think of this as high and low. Low is the bottom, so low is going to be the square root of x. Then we also need to think about what is the derivative of the high, so d high, and d low, the derivative of the low. Well, if we're trying to find the derivative of this top here, now we're going to have to use product rule, because product rule says now we're doing the derivative of this thing times this thing. So that's going to create, again, like a separate sub problem for us to figure out. So let's go ahead and take that over here. If we're now trying to say we're going to find the derivative of sine of x times x squared plus 2, we're going to have to use product rule. So let's go ahead and call that f and that g. We're just going to call sine of x f, all the rest of this stuff g. Then we need to figure out f prime and g prime. So f prime is just the derivative of sine x, or the derivative of whatever we call f. Derivative of sine is cosine. The derivative of g prime, is just the derivative of x squared plus 2. Derivative of x squared can be found with the power rule. We would bring our 2 down in front, lower the power by 1. 2 minus 1 is 1. X to the 1 is just x. And then the derivative of a constant is 0. So it's just going to be that. Okay. So now, again, product rule says we're going to multiply these across, do f times g prime, f prime times g, and then add them up. Again, order doesn't matter. Just make sure you're multiplying the right things times each other. Derivative of one times the other non-derivative. Derivative of one times the other non-derivative. So we're going to get sine of x times 2x plus cosine of x times x squared plus 2. Okay, so this is going to be the derivative. Let's call this y1 again, y1 prime. This function right here is the derivative of this function right here. Well, this function right here is what was the high, the top of our fraction in our quotient rule example. So if we go back over to our quotient rule problem now, if high is this thing, d high should just be the derivative of that thing, which is all this. So we're going to get all that right here. Okay, and then d low is just going to be the derivative of the low part of our fraction. Well, the derivative of the low part of our fraction is just the derivative of square root of x. Keep in mind, square root of x is the same as x to the 1/2 power, because taking the square root of something is exactly the same as raising it up to the 1/2 power. So to now take the derivative of x to the 1/2, all we have to do is power rule. We can bring our 1/2 down in front, bring our power down in front, keep our x as x, and then lower our power by 1. 1/2 minus 1 is the same as 1/2 minus 2/2, which is the same as negative 1/2. So our power is now going to be negative 1/2. Okay, so now we have these four pieces, high, low, d high, d low. And now I can just use this quotient rule formula. So let's go ahead and do that now. So that's just going to be low times d high. So low, x to the 1/2. So y prime is going to be x to the 1/2 times d high, which is all this right here. Make sure to put that all in parentheses, because you want this, this x to the 1/2 needs to distribute to both of these terms here. Okay, and then we're going to get minus high d low, so minus high minus all this, times d low, so times 1/2 x to the negative 1/2, and then all over low squared, so all over the square root of x squared. The square root of x squared is just going to be x, because the square root and the squared will cancel out. So that's just going to be all over x. So from here, there definitely is going to be some simplifying that you could do. I'm going to go ahead and leave that to you. So I'm going to go ahead and leave our final answer right here. If you want to do some simplification, go right ahead. There should definitely be some simplifying you can do with this numerator here. and this denominator, but I'll go ahead and leave that to you. So I'm not seeing any questions in the live chat. Those are the two examples I had prepared for you today. So we'll go ahead and wrap things up there. If you did find this video helpful, please do me a huge favor and go ahead and hit that like button down below. Really helps get this video out to more people so we can keep growing the Jake's Math Lessons community, keep getting more and more people in on these live streams, hopefully. So yeah, hit that like button, hit that subscribe button, and I'll keep helping you through calculus as you keep going. Hopefully we can get your grades up and get you doing pretty well in your calculus class. And that way you'll be notified of all my new videos and when I'm going live each week. So please go ahead and click those buttons down there. And thank you. Appreciate it. And we'll see you next time.